Hi, Dr. Revis here, and this is for Chem 111 for all my sections. I'm going to review Chapter 2 exam. I'm going to have to look down to do that, so I won't be looking at the camera, just letting you know that. So I will talk about the 8:30 sections and the 4 p.m. So I'll say morning and evening, and I'm going to go through the exam and highlight some things, and along the way I'm going to give you some tips on some things that you're not doing that's costing you points. So be aware that that's what we're going to do here. So I suggest that you get your exam paper and you walk through it with me. I'm going to go at a pretty good pace simply because I don't want to take up all your time. Okay? And so I'll go between the AM and the PM courses as we go through this. All right, so let's start with number one. And at the end of this, I promise to tell you some things that help you improve your scores and areas where it appears that I'm picking on you. It may feel like that, but that's not the case. Okay, let's take a look at number one, where we talk about which of the following elements, circle it, has similar properties to. In the morning class, we had fluorine, and the answer would have been bromine because they're both halogens in group 17. The purpose of this was to emphasize knowing the groups. Also, other places in the exam was emphasize knowing the family of groups. And we talked about that in the lectures, okay? For the PM class, it was chlorine, so the answer would be bromine. Same thing, halogen. For the morning class, B, silicon. Silicon, the similar compound, some said none. But recall, silicon is a metalloid. What's the other metalloid? Arsenic. We talked about that when we talked about the staircase, the periodic table staircase, and we talked about it when we talked about electronics. By the way, all of these questions can be tracked back to a slide. A few students were upset because they said, this doesn't look like anything I've taught them. If you like to settle down and talk with me for a little bit, I can show you each slide, and we can go back through all of my lectures and show you where they're tied to the slides. My slides are the study guide. Okay, so be aware that there were no tricks on here. Everything was just like that. Recall we talked about metalloids, right? So these are metalloids. That's what we're doing. Arsenic for the PM class and silicon would have been metalloids. And we asked which periodic table family of elements. For arsenic, it would be the metalloids, and also for silicon, it would be metalloids. So you may recall now that we did talk about metalloids and how all of these along the staircase had similar properties. We did talk about the halogens, how all of the halogens have similar properties. So this was teaching the groups and the families on the periodic table. And you may recall we said you do well to memorize these groups and these families. Okay, so let's take a look at question number 2. It says complete the table. By the way, when we ask you to complete the table, please, on the next exam, do not leave out anything from the table. We need to see the entire table, okay, when we do this. And please, another thing, do not renumber my exam. Some of you caused a little slowdown in terms of grading because it was new number. And you might say, well, that's my problem. It is my problem. But I'm going to transfer my problem to you if it happens again by not grading it. Okay, so be aware. Please number it. That helps us to keep the process going. All right. So number 2, ready? Here we go. So in the case of the morning class, we had 10, atomic number 50. Therefore, the protons 50. The number of neutrons is 55 because we have the the number of neutrons I gave you at 55. So we know the neutrons plus the protons gives us the mass number. And when you write the nuclear symbol, someone said they'd never seen that before. Look in the slides. You will see a table that looks exactly like this for all intents and purposes. And in fact, in recitation, you may recall I extended the table to talk about electrons as well. So the number of electrons are 50 for 10 because it is neutral. Okay? Now, let's drop down to the next one where we have the second row. Second row, we have 15, which tells us that the atomic number, it tells us this is phosphorus. However, go over to the far right and you'll see the number of electrons, 18, which is higher than 15, which tells us we have 3 more electrons. You recall I talked about being electron high, electron low. I drew arrows on the diagram to illustrate that. So again, all of this information was there and we had talked about it. So that symbol should be P minus 3. Phosphorus and phosphorus minus 3 are different. Yes, it represents the same basic element, but the form, the electronic structure of that element is different. So you can't call it just phosphorus when it has 3 more electrons. You have to tell me that that is an ion. You get it? And we talked about ions, cations, anions. You got it? So that's how we know that's P minus 3. Okay? So we have P minus 3, 15, 17 for the number of neutrons, because we have the mass number, which is 32. And so we subtract and we get the answer there. The nuclear symbol must also say P minus 3 because it's phosphorus minus 3. It is the ion. And we work through these ions in the recitations. So those of you in the recitation may recall that now. Okay? So there you have that. Now, something else that I noticed. Some of you will recall that I said the mass number is never a decimal. Well, someone must have forgotten it or didn't attend the lectures because I talked a lot about that. That never, 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 we wrote on the slide, said no decimals when it comes to mass number. Several of you put decimals. That's suggesting to me that you might not be listening to the videos or you might not be attending the lectures. I won't know, okay? All right, but there are some hints that some people are missing the lecture because that was one that we spent a lot of time talking about. And some people had decimals. Just thought I'd make you aware of that. All right? That was the morning class. For the afternoon class, same comments as the morning, except let's go through the values for you. Germanium. By the way, someone had capital G and capital E. I thought that was General Electric. Germanium is not uppercase G and uppercase E. It is uppercase G and lowercase e. Now, I did not take the points this time, but if you don't put the symbols correctly, I'm going to take the points because that's not germanium. You have to be precise. Chapter 1. That was the purpose of Chapter 1. We talked about that. Okay, being precise, knowing the elements in the periodic table, and we talked about they have to be exactly what they are. Okay, so you're going to lose points the next time on that. So we have germanium in the afternoon, 32, 32, 35 neutrons, 67 is mass number, and then we write GE 67 over 32, and we have 32 electrons. When we went to the next row down, we saw 33, which is the atomic number for arsenic. Therefore, we go to arsenic. But then if we look at the number of electrons, we have 36, which means we are 3 electrons high, which means we must say arsenic minus 3. Yeah, now you recall when we went over that in the recitations, right? Okay? And so the rest of it follows over 33. So the symbol is arsenic minus 3. The atomic number is, of course, 33. Then the protons would be 33. The number of neutrons is 35 because 35 plus 38 gives us 68. And the number of electrons, I gave you the number of electrons. That tells us 36, 36. And we have 33 protons. That tells us that we are high by 3 electrons. Arsenic minus 3 is not the same as arsenic. Okay, so yeah, you did lose points. Now, some of you are concerned that I don't give partial points. Typically, I do not. Okay, I try not to give you double jeopardy. If I take away early, I try not to take it away again. But I do not give partial points, and there's a reason. Saying that for example, in the medical field, if you're going to take Tylenol, you take a Tylenol. Extra strength Tylenol is not Tylenol. Okay, so you can't take partial points for something that isn't it. Someone say, well, I should have understood it. I can't assume that. Okay, because frankly, some people are going to just get lucky and write something down. Okay, you get it? So it's rare that you're going to get those partial points from me. Okay, it's either bromine or it's not. It's either arsenic minus 3 or it's not. I understand mistakes. Those we can deal with. But many of the things we saw here were not necessarily mistakes. They were just not the correct answer. Okay, you get it? So be aware that Tylenol is not extra strength Tylenol. They're not the same. Okay, a Ford is not a Chevrolet. They're vehicles, but a Ford is not a Chevrolet. It'd be like going into the hospital. The doctor orders up one set of meds, and you choose to give them another because, oh, that's close enough. Doesn't count. All right. So just be aware of that. So don't expect partial points. I hardly ever give them. Okay. Let's go back. Number 3. Ready for number 3? Here we go. Number 3 worked just like we did in the lecture. There are almost exact slides for this. So we went over this. So I'm not going to spend a lot of time with this. I'm going to say for number 3, please just look at the slides exactly like your slides. But let me point out some mistakes some people made. Some people did some really creative math. They like just multiplied the percentages, time it, and then they divide it by 3. Then they move the decimals over. A lot of page of math, but it's not that complicated. You simply have to take the percentage, convert it to a decimal by dividing by 100 or moving 2 places to the left. Multiply it times the isotope. You get the value, you add them, that's it. Nowhere in my slides do you see a division by 3 or some value. You don't see that in my slides. Now, some of you figured out the math, or you went over to the counseling center and they showed you how, well, you know what you could do? You could add them all up like this, divide by 100, then do something else. You could add them all up and then divide by 100. That's fine, as long as the math is sound. The other reason some of you lost points, you didn't put units on it. And some of you got creative, put your own unique units. Yeah, that's right. You lose points. We emphasize units, you may recall, okay, particularly in chapter 1, all right? And we talked about it again, yeah, chapter 1. All right, chapter 1, and yeah, we talked about it. So, enough of that. Same thing in the afternoon, same kinds of things. Some of you just did some really creative math for no reason. I mean, it was really creative in some cases, all right? But this is not that complicated. Look at my slides. There's everything I just talked about, 1, 2, 3. If you look at the slides or look at the recitation, you will see it exactly, okay? You will not see anything new. So here's something to know. Don't create any new math processes or new concepts that you haven't seen in the slides, okay? That happened for number 4 in morning and afternoon. So people got really creative. And this brings me to something that I have to renege on. I said that I was going to be okay if it was simple math. Some of you are trying tricks that you're calling simple math. You're setting up things and just poof, show me an answer. I can Google all these answers, okay? I know that. You know that. So I have to renege. Moving forward, you must show me all of your math now. Because some people, for example, number 3, wrote the first part of it and then just put some dots or parentheses and boom, showed me an answer. Not going to fly. So you must show me the answers. Chemistry is not psychology, and it's not history. We don't work by narratives and verbiage. We work by symbols. So please don't tell me magnesium, spell magnesium out, is a positive 2. You write Mg plus 2. That's how we communicate. And some of you got creative and you wrote narratives and convincing me that these charges are equal and they're the right charges. I won't go for that the next time. You must show me by math why you got the answer you got. Got it? So be aware of that. You must show me by math how you got the answers. Okay? So be aware of that because people are getting really creative in terms of it. And some of you are going to be frustrated because you say, well, you know what I meant. Not really. Okay? So be aware of that. So number 4, you had to show the crisscross. I specifically said that in the lecture and in the recitation that you must show me the crisscross. If you showed me the crisscross, I was going to accept your answers. Okay? But I reneged during the exam grading, and I gave points where perhaps I should not have because you did not have the crisscross. So if you showed me the crisscross, I was good. Okay? Naming the compounds, not much I could say. I warn you, memorize that. There's nothing we can do about that. You have ionic compounds, you have transition ionic compounds, and you have covalent molecular or what else? Yeah, molecular compounds and covalent compounds. Okay? That's one group. Molecular and covalent is one group. You have three groups, and that's what we're asking you to do. That's in the slides. The first one we did, magnesium phosphide, is ionic. You just have to simply learn how to name it. I can't do any more than tell you to memorize that again. Okay? And so that's, you just didn't memorize it. Not much else we can say about that. Let's see what else should we tell you about that one with naming the compounds. That's about it. Oh, naming the compounds. Some of you must have remembered from AP chemistry or just happened to pop in your brain common names, and you wrote those and you got no points, and you said, but that is the name. But we were teaching you IUPAC, and depending on where you Google, common name will pop up first. So be aware of that. We're teaching you IUPAC. So if you use Google, make sure you put IUPAC. Got it? For it. All right? So, not much else to say about 4 and 5. You just got to learn how to do them. Number 5, some of you had the right answer. Iron 2 for the morning class, iron 2 oxide, but you had the wrong charges in the A portion. How in the world you had the wrong charges in A and got the right answer in 2, I just don't know. But I gave you the points. But typically, if you have the wrong charges and you get the right answer, both are going to be wrong because I don't know where you got the answer from. You get it? So be aware of that. Having the right answer with the wrong charges just normally doesn't happen. Normally you have to get the charge first to get the correct answer. All right, so be aware of that. Same thing in the afternoon, saw the same case of manganese 2 oxide, and it's not small I, lowercase I, it's Roman numerals, okay, have to be there. So do not create any new forms of doing the chemistry and science, okay? Again, a Ford's a Ford, okay? A Chevy's a Chevy. These are also transition ionics, not just ionics, they're transition ionics. Someone used the term valley because you hear me saying it. When I say valley, I am just trying to help you locate it quickly on the periodic table. The proper name is transition. So I think moving forward, I might have to be a bit more formal in my presentations with you. But again, I like to paint pictures to help you remember where things are. But you can't use that terminology to tell me the type of compound this is. You can't call it a valley compound. You have to tell me it's a transition element. It is a transition ionic. You get it? You must use the chemical language. And when you use symbols, it must be the symbol, not words for the symbol. Okay? If manganese is +3, it must be cap, uppercase M, lowercase n, +3 at the top. Some of you put the charges at the bottom. I can't recall whether I took the points or not, but the next time you will lose them. The charge at the top means something. A value at the bottom has a completely different meaning. Okay, so be aware of that. Yes, I'm talking about being very precise. I'm trying to help you understand where you lost your points. You say, well, he's being picky. That's science. You want science to be picky. Okay? Otherwise, someone would be recommending that you do something silly with drugs. Okay? All right, so number 6 bothers some people, and I don't know why. I'm going to read number 6. Make a compound of group 15. So you go to group 15, step 1. Step 2, as a positive ion. It's written right there as positive ion. I cannot tell you how many people have the element as a negative, and it says the group 15 element is a positive ion with a value of 5. A positive ion with a 5 means a +5. Okay? We talked about that during the recitation, about how to know these things. Now, someone spent a fair amount of time discussing, well, they thought They looked on the periodic table and they saw this charge, and by God, that's what it had to be, and I was wrong. Well, I'm going to let you know a secret. I'm not wrong, number one. Okay? What we recall in the lecture, we said to you, the first part of every element, every compound is positive, and the second part of every compound is negative except for some exceptions. And we told you what those were, which mean in this case you have to take a plus 5 and combine it with a negative. And that's where you determine the negative when you count from the right side of the periodic table. When it's positive, we count from the left side of the periodic table. And I went through and drew an arrow in one of the recitations showing you that. So, but in this case, I told you it was plus 5. And some of you had minuses, so right away you're going to lose it. What that told me was you did not catch the concept of plus and minus in making compounds. And that is critical. That is a critical concept. So that's what happened with number 5. You can see the rest of it online, okay? So you had to take a plus 5 and combine it with anything else you wanted to. Some of you were really smart because you took the plus 5 and the minus 1. Thumbs up to you. Smartest way to go. Because that makes your nomenclature really easy. I was curious how many people would catch that. Say, gee, piece of cake. Take a plus 5 minus 1. I could write easy compound. Many of you caught that and did that. Some of you took minus 2 and worked as well. But some of you took minuses. Then some of you gave it a charge you wanted to give it. Someone gave phosphorus a plus 7 or something. And I'm saying it told you it was plus 5. Okay? That may frustrate you a little bit. By the way, I talk loud. My voice carries. It's heavy. I'm not frustrated, any of that kind of stuff. So I apologize if it comes off that way. It's just my nature. So yeah, watch for that. And then you have to name it according to the rules. Not much else I can say about that. You have to learn the rules. I can't do anything about that. And the hydrates, you may recall on the slides, we said, here are the hydrates. Anytime you want to hydrate, you have to name it according to the Greek nomenclature that's on a chart that goes di through whatever number it was on there. All right, it's a 2-column chart in the slides. And we show examples of the hydrates in the slides. And in this case, you have to rewrite the compound dot, not plus. Okay, I'm not sure whether I took off points for the plus or not. Dot the number of hydrates. The number of hydrates does not go at the bottom. That suggests to me that you missed that slide. I told you make sure you take a look at this slide because I'll very likely have a hydrate on there. Some of you took the liberty of putting a completely different compound there. Okay? If you Google hydrates, one of the large ones that comes up is magnesium sulfate. I saw a lot of magnesium sulfates there. I was not asking you to go ahead in chemistry. I was asking you to stick with this chapter. So be aware of that. So you see the answer there as well. So I just want to go over the concepts. And then number 7, I recall dealing with this and saying it over and over again that the periodic table as ions would be plus, more plus, because there are lots of metals. And I recall circling and saying, see right here, all these metals, therefore it's going to be plus, and the metals prefer to be oxidized. So the simple answer was plus, okay, because of metals. Some people say plus 1, plus 2, so you got a point. But it's just positive, okay, ions on the periodic table. So there you go. Just wanted to go over that with you because I thought this might be a good way to do it so that I don't take up so much time in recitations and lecture going over this. Hopefully the video comes over well enough to you. I'm not frustrated. We'll be talking more about what we do with this, but take your sheets, look through, walk through the concepts I've talked about, and let me just see are there any other things that I've missed that I wanted to talk about. I talked about using these common names. You'll have to Google to get the common names, unless you just happen to walk around knowing ferrous oxide. Okay. Nomenclature, you just got to learn it. Chemical formulas are written very specific. It talks about that in chapter 1, where we talk about the proportional, the law of multiple proportions, and we use the iron and the magnet, the rust and the magnet case. So go back, take a look at that. You don't put a plus between the hydrates; it's a dot. Yeah, some of you also seem to be working well ahead of me on some concepts that don't fit here. Some of you drew orbitals all over it and drew some forms of Lewis dot structures. If you haven't seen it in the slides, my slides are the study guide, okay? Then it's not going to work. Also, again, I want to reiterate, narratives don't fly with trying to convince me and sell me. You have to use chemical equations and chemical symbols. You have to put the +3, etc. above it. You have to show me when things have moved. You have to show me that it's electronically neutral moving forward from now on. I want to see that math. Okay? I must see the math to show me it's electronically neutral. Let's see. We talked about the plus side and the minus side. That's all in the slides. The isotopic table. Please don't renumber the tables and keep everything in order. We would appreciate that. Charge balance. But some of you looked on the periodic table and just took charges off of that. Okay, it depends on whether or not you're making a ionic compound or you're making a molecular compound. But the first part of all compounds are plus, the second part's minus. You just have to keep that in mind. We'll talk later about some other things we're going to do. I think I've covered all my points that I needed to. Again, hopefully the video comes across and works for you. If it doesn't, let's sit down, let's talk. Please show up for the recitations and ask your questions. You got to work your problems, okay? All right, guys, we'll figure out a way to help you get through this. Some of you have the ideas, but you are somewhat sloppy with the execution. That's all, okay? You're taking things for granted, all right? So be careful there, all right? All right, thanks a lot. I think we'll just stop the video here somewhere, and that's enough for now.